So in this lesson, we're going to be looking at how to write and graph inequalities. We're going to use this in many ways, from an English sentence into a mathematical one, from the mathematical into English, then from graphs into either of the other two. So first, what is an inequality? Well, shortly, by definition, this is a comparison of mathematical expressions that do not equal one another. Now, that comparison can be of the form of the first being greater than the second. It can be less than, can be greater than or equal to. Now, the definition states that they're not equal, but this does give the option of that one-sided greater than. We can have less than or equal to, and we can quite simply have not equal. As long as there is some sort of range of values rather than specific points, we have an inequality. Now, a solution to an inequality is the set of values that make the inequality true. Now, part of working with inequalities is having the vocabulary to associate with them. In equations with items that are equal, typically the word or statement that is used to denote an equation or that equal sign is the word is. 2 plus 3 is 5. But in inequalities, we can have a wide range of values. So let's take a look at some of them. So let's take a look using this chart at different terms that can be used. Now, our first symbol, we can use the term is greater than. But anything that helps to denote this idea will also work, such as above or higher. Our next symbol will be the contraries or the antonyms of these, such as is less than, below, or under. Anything that denotes this one-sidedness as a strict item can be used for these first two symbols. Our next two go along with these, but they do have the option of being equal, so they do carry along some extra vocabulary with that. For instance, symbol number 3 reads is greater than or equal to. That's the name of the symbol. But we can also denote this with either the terms at least or no less than. Symbol number 4 will work as the antonym of these, so we have the expressions is less than or equal to, at most, or no more than. Our fifth symbol don't actually use a whole lot in this level of mathematics in our study of Algebra 1, but it is out there, so this way you have it. This one can be read as is not equal to, or anything but. So if you see these terms and phrases, this will help you to denote those inequalities. Now, how can we go about translating from English into mathematics some of these terms? Let's take a look. So our first expression here, our first sentence, 5 is less than 1 more than 3 times a number, we can break down into its pieces. First, let's find the phrase that denotes our inequality. And the one that I see in here is this phrase, is less than. So that tells me right away I'm dealing with less than. Now, take the two sides. Our first side, 5, and our second side, or second expression, 1 more than 3 times a number. Well, 1 more than, so that means plus 1, 3 times a number, I can say 3x. Now, it doesn't specify what variable I'm supposed to use, but the term a number tells me it can be any number that I might need, so that has our variable in it. This translates out into 5 less than 3x plus 1. Next, a number, when decreased by 12, must be at least 7. So, again, we're going to find our term for the inequality first, and that is must be at least. Now, back to the chart that we had on the previous slide, at least tells me greater than or equal to. Now, what is it greater than or equal to? That tells us that it is 7. And then what is that? A number when decreased by 12. So some number decreased by 12 is greater than or equal to 7. Looking for the numbers, looking for the key phrases for the inequalities, as well as our other mathematical operations, helps us to be able to interpret these. Now, let's test an item. I want to know, is x equal to 5 a solution to either of these inequalities? Well, the way we do this is we test it by substituting in the value. So in our first one, we have 3x plus 1. I'm going to test the number 5, so 3 times 5 plus 1. 3 times 5 is 15, plus 1 is 16. So is 16 greater than 5, which was the other half of our inequality here? So the answer is yes. So in this case, 5 is a solution to this inequality. Is it the only solution? No. Anything that makes this true will work. Next, let's test 5 in our second expression. 5, that's replacing our x, minus 12 is supposed to be greater than or equal to 7. 5 minus 12 is negative 7. Is that greater than or equal to 7? The answer is no. So in our second inequality, 5 is not a solution. So if you're asked, is a certain item a solution, simply substitute it in for the variable and solve down, simplify the expressions, and see if the inequality holds true. Next up, we need to see what the graphs for these look like, since we are writing and graphing inequalities. So, series of inequalities. Our first one we're going to take a look at is the inequality m is less than 18. Now there's a lot of different ways to be able to graph inequalities, make it show up on the number line. I'm going to give you a couple of examples. The main number that we're curious about, in this case 18, has to be on your graph. So what I like to do is place this number as centrally located as possible, such as this. Then set up some sort of scale. Remember, in order to set a scale, you only need to number 2 items, but that scale has to be consistent. So I'm going to number my number line as such. I numbered every other line, but I numbered them with even numbers. So every line that you see represents a value of 1. Next, how do I denote this inequality? Well, m is supposed to be less than. On the number line, items that are to the left are smaller, to the right are bigger. And in order to denote that 18 is not an option, what I'm going to do is draw an empty circle centered at 18. Then, because I'm using a color that's easy to see and different than what is showing up on the board itself, I'm simply going to shade to the left in the direction of the inequality and put my arrow. So anything to the left of 18 would be a solution. The arrow denotes that it goes on continuously. Next, p is less than or equal to negative 7. So again, I need to put my number of interest, negative 7, onto my number line, and then number other things so I can set a scale. And then, what numbers am I curious about? Well, if p is less than, again, less is to the left, but this time it tells me that p can be less than or equal to. In order to denote this option that negative 7 is a possible solution, instead of putting an empty circle, I'm going to fill in my circle at negative 7. Now, you can see it's a little bit harder for me to tell where this item is at on my number line. So instead of coloring on the line itself, I'm going to go above it and then denote my direction of travel. This helps if you're taking a test with a pencil and the number line's already set up with black. If you simply color directly onto the black line, it might be hard to see. So by moving up a little bit and then in the direction that you want, it helps to helps the person who's grading and others who might see your work be able to tell where your solutions actually lie. Next inequality, we're going to be looking at W is greater than or equal to 2 76/100ths. So, again, place my number of interest in the middle, 2 76/100ths, and then note something to either side. I'm simply going to call my top value here 3. That sets a scale, even though I don't have to denote exactly what each line represents. It is greater than or equal to. Greater than is to the right. Equal to tells me that I have a filled in circle at my border number. And to the right is greater. Next, let's do H is greater than a -5/3. So, -5/3 goes in the middle of my number line, and I'm looking at greater than, so greater than items are to the right. A -5/3 allows me to put a 0 here, because larger numbers are to the right. I'm going to use an empty circle, since it's not equal is not an option, and then move to the right. Next one, let's do M is not equal to 6. What this means is M can be any number in existence except the number 6. So I'm going to put 6 at the center of my graph, number a little bit on either side, and I do not want 6, so open circle there. This time I'm going to denote to the left and right, or right and left as I drew them, to say that it can be anything else, just not this value 6. Now for our last one, let's do it a little bit differently. Let's take the graph and write the inequality that matches it. So you can tell that my border number is pi, so I'm going to write pi in as my expression. We're going items to the left. Now to the left are less than figures. So I have to be less than pi, and I can pick any variable I want. So just for the fun of it, let's use the variable L, and we have L is less than pi. So if you're given an inequality, you should be able to graph it. If you're shown a graph, you should be able to write it. And then from anything in between, if you're given an English expression or English sentence, write a mathematical one, and vice versa. So some new vocabulary, some items to keep note of for definitions, and some procedures. Make sure you have these and are ready to go forward.